Okay guys, welcome back to another video. In this video, we are going to look at the topics least common multiple. So the first thing we are going to look at is the definition of common multiple. So, what it states, an integer c is said to be a common multiple of integers a and b if A divides C and B divides C. Okay, so for example, 10 is a common multiple of what? Of 2 and 5. Okay, why? Because both 2 and 5 divides 10. Okay, so 10 is a common multiple of 2 and 5. Do we have another common multiple? 20, right? 20, 30, 40, 40, 50, 60, 70, and so on. Okay, now from definition of common multiples, we can say that 0, a times b minus a times b are always multiples of a and b. Okay, I gotta say common multiples of a and b. The reason is because a divides a times b and b divides a times b. Okay, so a and b are common multiples of a and b, and a divides minus a times b and b divides minus a times b. This means that minus ab is a common multiple of a and b, and 0 is also a common multiple of a and b because any integer divides 0. Okay, so that means that 0 is a common multiple of a and b. Okay, and here, take a look at this. A set of positive common multiples of two integers, let's say s, is not an empty set. Okay, because what do we have? We have 0, and the product of two numbers, and subtraction of the product of the two numbers. These are three common multiples of any two integers. Okay, now another one is, let's talk about a set of positive multiples of two integers. Let's say s is a subset of a set of natural numbers. So if s is a set of positive common multiple, set S is a subset of a set of natural number. That means that this set S satisfies the well-ordering principle. So what is well-ordering principle? Well-ordering principle. What is it? So if set S is a subset of a set of natural number and S is not empty set, we can say that there exists X in set S such that X is less than or equal to Y for all Y in a set S. Okay, that means that every subset of a set of natural number has the least elements. As you can see, X is less than or equal to Y for every Y in set S. That means that X is the minimum element in set S. So now this set S, which is a set of positive common multiples of two integers, is a subset of a set of natural numbers. So it satisfies the well-ordering principle. So we can say that this set S has the least elements. For example, if T is a set of common multiple of 8 and 10, and we know that the common multiples of 8 and 10 are 40, 80, 120, 160, 100, 200, okay, 240, and all the way and so on, okay. And then we have 40. We have 40, which is the least element in set T. So 40 is the least common multiple of 8 and 10. We might say that because of the well ordering principle, we can find the least common multiple of two numbers. And here is the definition of the least common multiple, and the notation for this is LCM of two numbers, or you might use angular bracket A and B. These are notation of least common multiple. So if we let A and B be integers such that A is not 0 and B is not 0, a positive integer m is said to be the least common multiple, or LCM, of integers A and B, which is denoted by angular bracket A and B and LCM of A and B. If and only if this m has the following properties. Number one, A divides m and B divides m. That's number one. Okay? So for number one, it says that m is just a common multiple. Now, how do we have the least common multiple? If you have every positive integer C and such that, or if A divides C and B divides C, then m is less than or equal to C. So if A and B, if the least common multiple of A and B is m, if and only if number one, A divides m and B divides m, okay, and for all positive integer C, if A divides C and B divides C, then m must be less than or equal to C. Okay, so this is the definition of the least common multiple. So from the definition of least common multiple, we have the following properties. So if A and B are integers such that A is not 0 and B is not 0, we have the following properties. Number one, the set of common multiples of A and B is an infinite set. For example, this set T right here, which is a set of common multiples, okay? And we're gonna have infinitely many common multiple, and it is a countably infinite set. Okay, it's a countably infinite set. And then number two, if m is a common multiple of A and B, then minus m is also a common multiple of A and B. Okay, and the least common multiple of A and B is equal to the least common multiple of B and A, equal to the least common multiple of A minus B, equal to LCM of minus AB, and it is equal to LCM of minus A and minus B. And number four, if A divides B, then the least common multiple of A and B equal to absolute value of B. Okay, let me think of this example. Let's say 5 divides 10. So the least common multiple of 5 and 10 is just 10, right? Absolute values of 10. Or you may have 2 divides minus, let's say, minus 10. So what is the least common multiple of 2 and minus 10? So it turns out to be absolute value of 10. Absolute value of 10 is 10, and 2 divides 10, and minus 10 divides 10. Okay, that's number 4. Now let's take a look at the next page. We'll take a look at the example of how to find the least common multiple. So the first thing that you have to do is to find common multiple of Okay, so the common, let's start with the multiple of 15. Multiple of 15 are these numbers. So you have 15. Okay, so we start with 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180, 195, this one to 2010, and all the way and so on. So you need to write all the number that such that 15 divided. Okay, so all these are, let's say k equal to 15q, where q is positive integer. And what about the multiple of 21? Okay, so you're gonna have 0, 21, 42, 63, 84, 105, 126, 147, 168, 189, and all the way and so on. As you can see, we have the common multiple. Okay, so next one is going to be 210 and all the way and so on. So you're gonna have the next common multiple, but we have to choose the least common multiple. So that means that the least common multiple of 15 and 21 is 105. Okay, and what is the least common multiple of minus 24 and minus 36? 72, right? It's going to be 72. Okay, and what about this one? What is the least common multiple of these two numbers? It's going to be quite large. So let me try to multiply this number by 4. Okay, I think I'm not gonna make it, right? Because 500, sorry, 54 times 4 is 216. It's not this one. Okay, it's going to be a hard time to find the least common multiple, but I'm going to tell you that this is 6,300,402. Okay, so these are the least common multiple of these pair of integers. Okay, so in the next video we're going to have the proof of the properties of common divisor, of the least common divisor, and you might have the statement that involve in the least common multiple and the greatest common divisor. Okay, so that's it for this video.